Yeah.
So this is now like for the last stage, right? The
last stage, yes.
Now we are talking about a lot of scale. People are like there is a concurrent transactions happening, right? And now we are not only worried about the scale, but also we need to make sure that there might be a security issue. Like even the attack can also consume your resources. The DDoS you mentioned, right? So we need to like make sure that everything is in place when you're actually scaling. So that strategy we have to of course start that planning. We have to start in the growth stage itself. But what are the different differences that you see when it is actually scaling compared to the growth stage? Are there any major architecture overhaul we need to do?
Yes, Praveen. Say when I was telling from growth to established, so we see eventually from gradually increasing from monolithic to microservices.
Yeah.
There might be a question that it is a compulsory to use microservices in all the architectures. The question is no, actually, again. It is not compulsory to use microservices in all the architectures. Since we know microservices, we can't directly do microservices.
Mm-hmm.
So we can say like this, say, for example, one monolithic is equal to one microservice. One monolithic is equal to many microservices. So like that, one monolithic can be mapped to one to many. There is a relation between monolithic to microservices, one to many microservices.
Mm-hmm.
Now, so when we see the mathematical model of these microservices, we can split this into three-dimensional things with an x-axis, y-axis, and z-axis.
Mm-hmm.
And say, for example, as I was telling you, one monolithic can be one microservice, or one monolithic can be equal to n microservices. Now, let us consider, say, for example, one microservice. Say, let us take one monolithic is equal to one microservice. That means if I deploy one monolithic means it is equal to one microservice. Now, in x-axis, what we do is we horizontally scale the instances of the microservices. This is because to distribute the load horizontally. So as I was telling you the incident of the product startup. So we started actually horizontally scale to increase, to meet the traffic load so that the performance of the scalability of the application started better.
Yeah, so compute you're mostly increasing horizontally.
Correct. So that is what we call it x-axis. Now, so the instances are split across a horizontal x-axis. Now, what next is, now functionality keeps on increasing. Now functionality starts. So now why can't actually, now I split this single monolithic to multiple microservices, each microservice catering to one function. So if you take a typical healthcare application, so say for example, patient-related functionality can be one microservice, doctor-related functionality can be one microservice, security itself is one microservice. So like that, we can split that into based on the functionalities we can have. So which is actually catered to y-axis. Now again, so these microservices, which is at the y-axis level, there's functional split. Now what about the data? So now do we need to partition the data? Say for example, why not actually the particular patient-related microservice can access only the patient-related information or patient-related data store? Why can't actually the doctor-related can store only the things or anything related to order management of healthcare instruments? So that why can't it access only the particular instrumental-related data or the order-related data? So all that actually is part of the z-axis data partition. So in that way, so we start with scaling the horizontal instances at the x-axis, and at the y-axis level, we split that based on the functionalities, and at the z-axis, we partition the data which caters to each microservice. So this is when we take this as a mathematical model, we can visualize like this.
Right. Okay, so that is like kind of an interesting thing, right? Basically, when you're talking about data partitioning, each microservice has its own data store, if I'm understood correctly, right? So in that case, how exactly the relations are meant? Like, is there any chance of data duplication here? Like,
yes, Praveen. Yeah, that is one very interesting question, actually. Yeah, when we split the data as a partition, the data model has to be designed very carefully. So because unlike in single database where we'll have multiple tables and the relationship between the tables with the foreign key, child key relationships and everything, all that cannot be achieved when we partition the data because the tables will be completely now, we cannot follow the exact normalization that we follow for RDBMs. So now all the data, for example, let us take the patient-related data will be stored in particular patient data store. and the doctor related will be stored in. So like that, we'll have the complete data partitions. And when we design the data model, we should be very careful in such a way. The dependency should be in such a way, they should also follow all the transactional based capabilities. When we say transactional based capabilities, say for example, let us take in healthcare, the patient related information associated with a particular doctor, okay, is there actually. So what will happen is, I will be having patient related information, one data store, doctor related information, another data store. The relation between these two is that patient will be associated with a particular doctor. So that means one patient to one doctor, okay, like that. So, but for one doctor, there will be many patients actually. So what will actually, we should have a primary entity at the things, but whenever any request that comes for a doctor related microservice, so that request has to fetch the data from the doctor related data store, and at the same time, from the doctor related microservice, it has to call internally the patient related microservice to get the patient related information.
So it's inter-micro communication, right?
Yeah, it is between the microservice to microservice communication. And we also need to ensure that the transactions are also proper. Like, for example, if the patient complete information is deleted, then automatically, or for example, if the doctor related information is deleted, then we should be ensured that the patient associated with the doctor also should be deleted so that the patient can be mapped to another doctor. So in this way, the transactions are to be managed very properly. Actually, for that, we can leverage some of the patterns like event sourcing patterns or messaging patterns, where any deletion or updation of the doctor-related microservice will trigger an event to the messaging queue, so that the patient-related microservice can consume that event and can update the patient-related data in such a way.
Exactly.
So, like that,
this is kind of asynchronous,
Yeah, it should be asynchronous. So, like that, the transactions is also good. See, this is what we call it as a distributed transaction management. There are different ways to achieve distributed transaction management, especially on the microservices level. So one, we can use the old way where we used to use JTA, which we call it as two-phase commit protocol, which we call distributed transaction using JTA.
Correct.
But that was actually a legacy approach, and it has led to performance implications. Then we can use, in the microservices world, we can use Saga patterns. That is one way. Or messaging queue patterns is another way. In that way, we can achieve all these transactions, especially when the data is partitioned across multiple microservices.
Considering, because we have different ways to handle the situation right now, like considering the security compliance in healthcare products specifically, because when we introduce more data stores or more service or systems, right? So, because for example, like if we're talking about event driven, then you might be thinking about the SQS, right? Or when it comes to the AWS. Now, like the queue is also storing some sort of data. Now, again, we need to take care of the HIPAA that side. So, like
exactly, Praveen. Exactly. Yes.
So, does when we are architecting, right? When you're actually building, solutioning these kind of a product. So, what is the best way to go with the plain approach, microservice to microservice synchronous communication, which doesn't store anything? Or you think okay, maybe we have to decide it carefully, understanding the PHI side of things, and then don't store that on the queue? Or does SQS also supports KMS encryption?
Yes, exactly. So yeah, definitely. So when we use intermediate stores like SQS or Kafka, these things, so they are already they have a mechanism to support data encryption at rest. So whatever the data stores that we are using in our architecture, everywhere at each and every piece, we have to consider the encryption at rest. And as I told you, they should not be exposed directly to the public network, and they should be protected from a private subnet. For example, if you take SQS or any RDS, so they should be accessible only from the VPC endpoints and only authorized users. And even to access SQS we cannot access directly without proper authorization. And the communication with the SQS to the microservice, everything should be SSL layer actually.
Right.
Where is the data interest? So we have to follow all these when we design this architecture. So we have to identify the components where the data is being stored at multiple places in our architecture. And also we have to identify the components where the data is flowing between one system to other system, and how the transport is being done, either through HTTPS or it's a plain TCP. So at all places, we have to follow the SSL mechanisms so that during transit also data is protected, and during the storage also data is protected. The data stores.
Correct. Glad that you answered that, because that was one of the question asked by the audience. Audience,
Sure.
please keep posting your questions under the Q&A section. As we get time, we'll definitely answer. And just to let you guys know, like one of the luckiest person who has definitely asked the right great question, he will going to get some Amazon voucher. I'll move to the next slide. So again, now like this, we discuss at high level, but again, you can just specifically put a focus here.
Yes, correct. So these are the things when we consider, as I was telling you, one monolithic can be one microservice, or one monolithic can be multiple microservices. So when we consider one to many between monolithic to microservices, so definitely now we are entering to the microservices based architecture for definitely high scalability and extensibility. So what are the things that we need to consider? The basic microservice principles like service discovery, the load balancing between the services, not only at the instance level, but within the service level. And as I was telling, self-healing capabilities, when I was explaining about the resiliency through circuit breaker, and the configurations also should be extendable and protectable. And the centralized logging mechanisms, where logging has to be proper as a part of monitoring mechanism. And also while logging, we should follow compliances like HIPAA in the healthcare, where the data is masked properly and all that. So when I say centralized logging, this is the logging across all the services. So these are the things that we should follow when we design this, when we split this into multiple services.
Awesome, great. So I will take one question from the audience. So from Sudesh,